Greetings to Doctor and all my classmates. I am Kavita Chongshilin, matrix number 299071, and our group today, Group 3, will be presenting about the comprehensive analysis of concrete in the Sydney Opera House. To begin with our comprehensive analysis of the Sydney Opera House, I will start by briefly introducing what is concrete. Concrete is one of the most vital and widely used materials in the global construction industry. By weight, its usage surpasses the combined total of steel, wood, plastics, and aluminium. The Sydney Opera House utilized various types of concrete throughout its construction, with the iconic shells composed of precast concrete panels supported by precast concrete ribs. Next, we will look into the materials analysis and the key components used in the Sydney Opera House. First, we have cement. The primary type of cement used was ordinary Portland cement, which we call as OPC, known for its versatility and stability in various concrete applications. It provides the necessary strength and durability for structural elements such as foundations and shells. The aggregates used in the concrete mix varied depending on the application. For mass concrete piles, coarse aggregate like gravel was used for consolidation and strength. For podiums and concourses, a mix of coarse and fine aggregate was utilized. Next, water quality was managed to ensure the concrete's durability. Clean water free from contaminants was used to maintain strength and performance. The quality of water added was controlled to achieve desired workability without compromising structural integrity. Lastly, various admixtures were employed to enhance specific properties of the concrete, including plasticizers, superplasticizers, waterproofing admixtures, and retarders or accelerators to control setting time.
I'm Chan Kai Xiang, matching number 298457. Today I'm gonna to discuss the properties of building construction. First, I will explain the physical properties of the Sydney Opera House. The Sydney Opera House shells are designed like the white shells and are constructed of more than 1 million tiers spread over an area of about 60.2 hectares of land. These tiers are made of clay and crushed stones, ensuring they are low density to meet structural support requirement. The lightweight tiers also help shed the dead load of the enormous concrete shells that form the main of roof structure. Study on the tiers' capillarity and insulating property were crucial for maintaining the temperature and humidity inside the performance veneers, which is critical for tuning musical instruments. The second is mechanical properties of the Sydney Opera House. These concrete shells were expected to bear very much of wind loads, seismic loads, and their self-weight. The mega column structure that were designed to bear the loads of the superstructure without failure were designed with high strength, pre-stressed concrete with a compressive strength of nearly 40 per 50 megapascal. Besides that, tensile strength was also considered important, since the shells are subjected to bending and tension forces. The application of high-strength steel cable in pre-stretching improved the tensile characteristic of the concrete and ensure that the distance between the shells could be opened up to a great span without cracking. Additionally, the modulus of elasticity of concrete, around 30 to 35 gigapascal, was carefully engineered to provide both stiffness and load-carrying capacity. Meanwhile, handling the thermal expansions and contraction of such large concrete structure was challenging. The shells were made of system of precast, rigged concrete segment joined with epoxy resin, allowing individual segments to expand and contract without generating damaging stresses. At the last, in enhancing the durability of the Sydney Opera House to withstand severe degradation factor through the building lifetime, several factors were put into consideration. The application of the strong in compression with high resistance to environmental structures was that of reinforced concrete, for example, wind, seismic, and other natural actions. On the tensile capacity, the concrete was pre-stressed to resist the wind and seismic load. Polarized glass and steel frames on the faces of the building gave exemplary resistance to wind and weathering. Thank you.
Hello everyone, my name is Shin Yuan Hong with the matrix number 29X62. So today I will telling about the production and construction process of the Sydney Opera House. The first process will be mixing. The concrete mix for the Sydney Opera House was crucial for its durability and strength. The mix include cement, water, sand, gravels, and admixtures like particizers and accelerator, precise metering and large-scale batch mixtures ensure a consistent mixture with strict quality controls and regular testing. And the second one will be placing. Placing the concrete involved designing custom framework to fit the opera house unicorn curve. Reinforcements bar were added for strength, and concrete was powdered in layer and compacted with vibrator to eliminate air pockets. And the innovative scaffolding system supported the frameworks and workers. Third will be curing. Curing ensures concrete achieves its desired properties. This was challenging due to Sydney fracturing climates. Technical like curing blankage, membranous, and regular water spreading keep the concrete moist and preventing cracks and promoting proper cement hydration. And fourth will be precast concrete. Precast concrete were crucial for efficiency and precision. Components were cased in a controlled environment ensuring high quality, and this accelerated the project as site preparation and casting occurred simultaneously. However, transporting and assembling this large piece required a careful planning and specialized equipment. Next is post-tensioning. Post-tensioning enhanced the concrete structural capacity. Steel tendons were embedded in the concrete and tensioning after stacking, and this allowed the concrete to support greater loads and span longer distance, essential for the opera house team's grateful self. And six is custom formwork and scaffolding. The Opera House complex shed required custom formwork and scaffolding. Materials like steel and high-strength plywood were used, and innovative scaffolding systems were modular and adjustable, ensuring safety and allowing workers to access high and difficult to reach areas. And last is advantage surveying and alignment technical. Precision ways key is constructing the opera house, laser alignment tools and 3D modeling ensuring accurate placement for formworks and precase pieces. This advantage technical reduce errors and increase efficiency helping to meet the project's design specification. Here are the challenges and solutions while building the opera house. The project to face the several challenges, including complex geometric, material properties, climate conditions, structural stability, and logistics. Solutions include custom formworks, comprehensive tests, curing technicals, post-tensioning, and precise planning and coordinates.
Warm greetings, Doctor. I'm Bjtc from class Bjtc 2023 Group A, and my metric number is 300407. And I'll be presenting the testing of concrete of Sydney Opera House. The Sydney Opera House undergoes numerous conservation and restoration projects to ensure its long-term durability and structural integrity. Standard tests and unit projects help to evaluate the condition of the concrete without causing damage to the structure. In addition, specialized tests is also conducted in this construction project according to their requirements. Through a combination of standard and specialized tests, the Sydney Opera House went through meticulous and continuous evaluation. These efforts are essential to maintain its structural integrity and heritage value, ensuring that this architectural masterpiece can be enjoyed by future generations. The standard test includes both slump tests and compressive strength tests. The slump test measures the concrete consistency and workability by filling a cone with concrete, tapping it in layers around 15 times, and lifting the cone to observe the subsidence, indicating how workable the concrete was for the intricate shapes. The compressive strength test determines the concrete's load-bearing capacity by casting, curing, and then crushing samples under increasing loads. The compressive strength can be calculated by dividing the maximum load by the sample's area. Through rigorous slump and compressive strength tests, the Sydney Opera House stands as a testament to precision in concrete construction, ensuring it could support the structure's unique shells and remain a durable, stable icon. In addition to standard tests, specialized testing is often required for unique structural or environmental needs. An example is the tap testing of the Sydney Opera House by using a tapping hammer and a microphone. For every 5 years, inspection engineers abseil the structure to tap test the tiles, which are fixed to concrete lids on the sills. This test checks for changes in sound or appearance, serving as a concrete conservation strategy. According to the Sydney Opera House 2018 final report, non-destructive testing methodologies such as ground-penetrating radar, ultrasonic pulse echo imaging, and vibration speakers are also conducted. Ultrasonic pulse echo imaging evaluates air gaps in concrete ribs by analyzing high-frequency sound waves to detect damage and defects, while ground-penetrating radar assesses the position of steel reinforcement in the rib cage area.
My name is Hong Yi Kai. Number matrix is 298169. So in the part is 6.0. There is architecture and technologies innovations in the Sydney Opera House. So I will present the 6.1 is the architectural signification and specific use of concrete in the Sydney Opera House. There is a have a three step. Is a step one is a 1959 to 1963, and the step two is a 1963 to 1967, and the last stage is a 1967 until 1973. In the stage one, the government initially planned to start construction immediately due to financial and public concerns. However, architect John Hewson had not finalized the blueprints, and this building structural integrity was a major concern. Start construction too early led to serious issues, including the need of the roof columns replacements. And then the stage two is a the shape of the building roof shell was unclear. Designers initially considered creating curving arches supported by factory-made concrete ribs, but could not construct them due to the high cost of making walls and the distinct nature for each roof elements. From 1957 to 1963, they experimented with 12 methods for creating roof shells, including curved form. Computers were used to determine structural integrity, help them understand complex root focus. In 1961, they decided to create all shell as portion of a shape form. In the last stage, architecture users relate to Sydney to work on building in 1963. So in the 1965, the new government took control leaded to users registration in 1966. By October 1966, they had spent 22.9 million, less than a quarter for the final cost of 102 million. They believe the rest of the project will cost more. So, and 6.2 is an innovative concrete technologies employed in the Sydney Opera House. The Sydney Opera House innovative concrete construction design has inspired many designers, leading to impressive accomplishment in the future project. The Sydney Opera House uses aero buildings technology such as pouring concrete onto tiles, which is a unique method that enables precise installation and handles temperature fluctuations. This innovative approach has been applied to bridge construction worldwide, such as Singapore's Julie Beach Bridge and a massive cable stayed bridge and in Corpus Christi, Texas. So I finished my part. I will pass my next partner.
To conclude our presentation, the Sydney Opera House is a testament to the evolution of concrete technology and its application in iconic structures. Innovations from this project have influenced global construction techniques, symbolizing the successful integration of architectural vision and engineering expertise. That's all from our group. Thank you and have a great day.